chat. You can hear me? Okay, thanks. Welcome aboard. Let's see what we can do. And like I mentioned in my last class, I will pick a few steps behind so that we can be able to link where we left and where we are to start today. And one of the things we discussed was the tiered architecture. So in a distributed environment, we have discussed on some of our lessons. One of the things we have in system, you have a data storage in one location, you might have your interface in another location, and you might have the processing of that application in one location. So in this case, therefore, what we had is that you can have even server users have a user interface level, one location, a processing level, one location, and a data level. And all this can be distributed on 3 different machines. Now, one thing that we mentioned in this, that when you do that, we end up saying that some of these machines is one location or one node that requests for service, and the server as one location that requests for service. I mean, provides the services that are requested. So if we are having the 3-tier architecture, for example, we might have something like this one here, where we are saying that you have this as your client, which will make a request. Remember, it will make a request to this one here as a server. Now, remember, the message is going downwards. So if I use an arrow, for example, if I use an arrow, for example, this one here, we are saying, therefore, that, again, the middle one here will request here, this one to provide a service. So we have the first one there, okay, which requests a service, which goes to the application server, which acts as a client and sends the message to the database server. And then we have, on our way back, we'll now have the result is brought to the location here. And then this one now receives it as a client before, but it becomes a server, which sends the message back to this. So in this case now, we have that our result is going back to this end here. Okay, so we end up having a scenario where we are saying that the server was acting as a client, and this is very common in a vertical distribution. So if I one to the next one, from that one to the next one, and then when the result is processed, okay, which is basically here, okay, and then it's vertical. You can see it's vertical distribution. This vertical distribution, we have another application on the internet whereby we end up what we refer to as horizontal distribution. Like they are the same level. For example, let's look at this one here. So this is a front end. Now, a front end which gets requests. For example, let's assume all of us are trying to write maybe an email, and so we are using a Gmail server. And so when we make a request, okay, maybe the first one of us who is queued might be taken to this server. The second one might be taken to the next one. The third one might be taken to the other one. So these are behaving in what we refer to as a round-robin fashion. Round-robin means the first request goes to the first server, the second one goes to the second server, the third one goes to the third server, all the way. The point is this, that we do not, in this case here, we don't end up overloading one. Now, so one of the first questions that can arise on your mind is, how is it that when at the end of this, the result is not inconsistent? So this round robin structure we'll discuss later on, whereby it does what we call updates. So it ensures that, like for example, if you apply, a request came to the first server, and then when you are coming in, it goes to a different server, they will have to ensure that there's an update for consistency. So this is called horizontal distribution, because you can see the servers have more or less at a point where no action or no request is being made, they are stable. So that means the result, the content is exactly the same. So the content of your email is stored at different locations when it's stable. Immediately you update, then the others are told to update to have that. So this differentiate too, we call this horizontal distribution. So, and this is enhances the performance of a distributed system, because it makes it easier for any different, one, to ensure that we don't have a bottleneck. Remember, when we have only one central location, that's a bottleneck. Maybe let me go back here and give an example. If you don't organize your database well, your distributed system well, and you only have one like this one, where we have several requests coming to, that's a potential bottleneck. Okay, so a round robin structure eliminates the concept of a bottleneck, which means that you can have services provided from different locations. Now, the implementation of a distributed system, we said we use the concept of remote procedure calls. Now, remote procedure calls, okay, Birrell and Nelson 1984 paper, they had what a seminal contribution, founding, which was very, very unique at that particular moment of time, but it was the one that led to this concept of distributed applications. So in this case, the purpose was to allow programs to call procedures located on different machines. Now, so effectively, what we end up removing is that now programmer, you remove from the programmer the concept of network programming. So you don't have to say, I am writing this particular program here, and I need to know the socket or where this particular program is going to end. Okay, I need to know the access point. So when you're using remote procedure call, it removes that. Okay, so basically you don't have to say, I need to know the socket where this is being accessed. And so the remote procedure call will handle that. So we'll see how that is done later on, but basically it removed that. So you program without necessarily thinking about your access point on that particular location you're trying to access. Of course, it looks conceptually simple, yes, but it brings in other issues. Okay, so let's think about individual issues that comes when you're looking at this concept here. Okay, so one of the first things that comes in is complications. So the complications that come in here are, supposing we have two different machines. Okay, we have two different machines here that may not be identical. So we have talked before that we might have different machines with different architecture. So they might have different address spaces. Okay, they might have ways in which the actual memory locations are. Okay, by the actual memory running that particular program. Some of them might refer to random access memory. Some might refer to virtual memory. Some refer to a combination of both. So this means that we have some complexity there. Okay, and so this complexity here will be very difficult if we did not have this concept here of the remote procedure call. Okay, and in fact, the others, like for example, we might have parameters are also different. The way they are passed, the way they are organized, the way they are marshaled, I mean, the way they are marshaled from one to another is different. So what happens there? If, or in some cases where we have both machines, one or both machines are going to crash. Okay, so you have made your request and one or both machines are going to crash. So do crash. So what will happen? So these are complications, okay, and these are more when you're using remote procedure calls. Remember, in our discussion, we said we want people to use the environment they're familiar with. Okay, so let's see how some of these complications are solved. Okay, so remote procedure call, basically, we have said that you are saying when you are using a remote procedure call, that you are calling a remote procedure call that looks more like a local procedure call. So it's like me, I'm calling that procedure call on my program, and remote procedure call would be a different program. Now, let me extend this and say I'm making a local procedure call on my node, in this case, my client, and I'm accessing another location that is on a remote location. So the remote procedure call allows us now to hide. Remember this concept here. This concept here allows us to be able now to implement transparency. It's achieved because whether I'm making a local procedure call or I'm making a remote procedure call, it just looks like a local procedure call, and hence transparency. Remember, so we have hidden whether that location is where you are or that location might be on the other side of the globe. So hence transparency is achieved. Let's look at this concept again of local procedure call. So if you remember a simple program here, so I have a foo_bar. So if you look on my my stack, okay, I have on my stack here. So I have X, Y, of course Z from 0 to 4, because remember, if you're looking at what we had here, we int Z is 5. So we have that information there. So when you start at 4, this is the stack pointer. When you go to 2, this is the stack pointer. So it will have to implement all these ones here until it gets to the return point. Okay, so that's how you put information on a stack, and that is a local procedure call. So remember, foo_bar is being called from void main. Okay, and so was carried from there, and then we go to foo_bar. Now, in this case, we end up saying that basically we have a transferred control from here. Sorry, it was not being seen. Transferred control, and then on top of the stack, and then we have all these items here, that are implemented, and we go to 2, and then come back later on at 1. So that is a local procedure call. Now, so the same thing we are saying can be implemented in a remote procedure call. So how does that remote procedure call work? Because for you to have that remote procedure call, we are saying that you have local environment and you are trying to implement a remote environment. So you must have preparation. So you have the clients tab, which prepares the message, okay? And then we have the servers tab, which implements. So the servers tab does the actual work, okay? So it will do the actual, while the clients tab will just be able now to reorganize that, implements the interface, but simply reorganizes the information so that it can be implemented by a remote functionality. But for us to do this, therefore, we need to ensure that we marshal. Remember in our last class, we mentioned about marshalling, which basically means we reorganize that information so that it can be understood by the server. Now, so look at it. Supposing we are speaking different languages, it must be converted such that it can be understood by that particular server. So that's what we mean by marshalling here. And then after we have done that, of course, we send it on a communication module, which is transferred across. And that's what we discussed before, whereby we have the communication chart. So it uses the same communication structure that we have talked about before. So parameters are marshaled by the client prior to transmission or on the transmission to the particular server that you are going to use. So marshalling is conversion. So if they want the same architectures, there's no conversion that will be done. If there are different architectures, they have to be done. Okay. So therefore, the client here will use the client stub and then marshal the information, which is transferred. Okay, which is transferred from here to the next location. Then at that location, we have the server stub, which will unmarshal that information, process that request, and then after that, marshals the information. Okay, after it has processed, marshals the information and taken back. Look at it this way: you write information, which was in French, it's taken, it's converted to Italian, processed, that converts that language back to French and is sent back, and then you can be able to receive the result back here in French. So what I'm saying, marshalling is to make sure, and in this case, we are saying you have different architecture, so it has to be converted in a way that can be received by this. So if we try to put that in a process that looks at the steps, then we have something like this. So we have, first of all, we have the client here, client stub, which will be the message, okay? And it will send this to the operating system. So, and then when it reads the message, it gives it to the local operating system, which sends to the remote operating system. That remote operating system will give it to the client, to the server stub, which unpacks the message, okay? And then back to the server. Then the server will unpack that particular message, call the local operating system, and the local operating system will send that message to the client operating system, and the client operating system gives it to the client stub, and the client stub will unpack that particular result. Okay, so you notice now that the client, and that's why if I go back here, that's why the clients used one architecture to send, and it's getting back the result in the same architecture. That was handled by the use of the client stub and the server stub in marshalling. In our last class, we mentioned that is called external data representation, XDR. Now, so we could enhance this diagram, this to a diagrammatic format where we now have, okay, let me maybe change to something like this. So I have here, it takes it to the cloud, okay, here, which will marshal that information. Then it sends it to its operating system, which sends it on a network. The network on the remote side receives that information, okay? It gives it to the server stub, which unmarshals and gives it to the server, which will handle that particular request. And then the message after that, the procedure will be exactly the same, and it will come back to the client. So it will come to this location here, then from here come to this location here, and from here it comes back to the client. So if you notice from here, therefore, what I have here, that it's this particular client that made that request. It looks like it was just a procedure call. It does not even care whether that message went all the way to Europe or it went just on the same computer itself that you're trying to process. To the client, it looks like just like a local procedure call. But you know, this procedure here this server here might be side of the globe. And this gives us the opportunity now of using servers that are extensively distributed across the globe, because the client, in the way it implements this, it looks like local procedure calls. And you have noticed, it's not even noticed that there were differences in the different architectures. Of course, just to recap something I mentioned earlier on, there were problems. Okay, so when you're looking at this, please remember that there were problems there. The machines might not be homogeneous. Okay, so if it really works well when the machines are homogeneous, but they might not be homogeneous. Okay, so complications can occur, and of course we have seen the solution, XDR, because maybe we are using ASCII, okay, which is 128 characters, or the extended binary coded digital information interchange, which includes all characters, Chinese, maybe Japanese characters, whichever way, and it has to be able to convert. Of course, there's the other part, which was the byte ordering. So it might be big endian, more significant bit first, or little endian, which has the least significant bit first. And here I'm saying you're looking at it from left to right. Okay, so let me use from left to right. So when I say big endian, I'm saying we have, if I'm writing 1 to 4, then 1 is the most significant bit, because that is, let's say, 124. While 4 is the least significant bit. The little endian will do the opposite, so we'll have 4 to 1. So that means that we, in the remote procedure call, we need to build extra mechanisms that are required to ensure that the remote procedure call can be able to provide these services. Of course, this adds complexity to your design. Okay, so it's important when you're looking at this to always consider, though it looks simple, but there are complexity that are involved in terms of this. Okay, so maybe let me complete the implementation of this, and then I can field questions so that we can move ahead in regard to this. So therefore, just to simplify, the asynchronous remote procedure call. Remember, asynchronous means that irregular intervals. So we have here, so we have the client makes a request, it goes to the server, and then the result is brought back. Okay, you notice on this diagram here, what I have done, there's something that is happening here. This part here, the client is waiting for the result. So it has to wait for the result from here to here. That is time wasted. So we can change that a bit to have what we call asynchronous, and say that instead of the server, the client waiting for the server to process and return a result later on, what the server will do, it will receive the result, the request, and immediately accept the response, in the sense that now the client can proceed with other work. Now, there are two reasons we could do this. One of the reasons might be you are not expecting a result. Maybe it was just a notification. Another one will be is that the client, the server, will take time to process the result. And hence, what will happen is that it tells I have received your request, yes. Go ahead and do other things that you are doing. I'll come back to you with the result later on. So this process of waiting is called blocking. So we are saying that the client has what we call blocking. Blocking occurs. Okay, so this asynchronous call removes the concept of blocking. Okay, so let me use this one here. I'm saying the asynchronous call removes blocking, and this is what we have here. So here, and then the result, the response is simply acknowledgement, and so a synchronous remote procedure call removes blocking. The client can continue with other work if it has, and then the result will come back later on. So let's try to have a scenario where the result will come back. Okay, so in this case where we'll have a result back, okay, so it makes a request, These ones gets the request, acknowledges. The client continues with some work it was doing. Server continues to process, and after that, the server finishes, it brings the result back. And that's why you can see this moment, the client acknowledges that a result has been brought back. So we refer to this as deferred asynchronous remote procedure calls. The result is deferred and it can be brought back later. So this usually is useful in some cases when you don't expect a result. So the client can continue with doing other things and it will just get a response later on, an acknowledgement. Oh, whatever you requested, we have maybe implemented it, whatever. And so I'm just trying to acknowledge that that remained earlier on. So this is called deferred remote procedure call. Okay, so let's few questions. So respond to that. Okay, so let's see. Anyone with us there that you might want me to refer to? But to okay, so I have two questions here. Someone asked me to explain asynchronous remote procedure call, and then of course mechanism where blocking occurs, and then when mentioning remote procedure call, what do you mean by machines being homogeneous? So I'll start with the last one there. Machine homogeneous means they are of the same architecture. Okay, homogeneous means the machines are of the same architecture. So your machine, maybe as the client, and my machine as the server have exactly the same architecture. So that is homogeneous. And then let's go to asynchronous remote procedure call here. In the asynchronous remote procedure call here, what we are saying here, the first thing was about blocking. Okay, blocking here, I meant this part here. The client was waiting for a result. And notice the dotted line there. So it was not doing any work. It was waiting for a result so that it can process. That's called blocking. So you cannot continue with your work because you have not, the implementation of what you want to do depends on the result coming back. So you have to wait. Or similarly, you have not organized it such that you have to wait for the result. So the best way will be, I can have multiple cases. So when this one is happening, the other one is, I am waiting for it. So that's what is called blocking. So therefore, the second case here, where we don't have, let me use a rectangle here, where, notice the arrow just came in from here, like this, okay, and the result was sent back. Acknowledgement was sent back. So that is no blocking, okay? So that is what we call asynchronous remote procedure call. And it's called asynchronous in the sense that different requests will have different time spans. Okay, so I might send to server A, I get it after 2 seconds. I send to server B, I get it after 5 seconds. So asynchronous always referred to as irregular time intervals. Okay, so whenever you hear the term asynchronous, remember it's irregular time intervals. Okay, so the other question, let me go back to the chart. Okay, well, let me clear this. So there is the mechanism where blocking occurs known as synchronous remote procedure call, where blocking occurs. No. We wouldn't want to call it a Sorry about that. I had a blackout, but I'm online. Please confirm you can hear me. Yeah, I'm hoping so that good. Sorry, that was a blackout on my side, but I think it's fine. So this on this part here, let me go to the chart that we had. Okay, so what we had here, this deferred. There was a question on this. Deferred therefore meant that you had this one here, a request, then you get this one here, where it makes the server receives it, and then you have this, where you end up having the acknowledgement. Then the process, the server continues processing. The client continues with the processing. Then a result will come back later on, okay? A result comes back later on. And if I just clear that part, you notice something there. Notice here, notice that part. There's that interrupt, there's that space in between, okay? And that's what we call you interrupt the client. And when you interrupt the client, the result that what you are saying, you are asking for before you have brought it back. Okay, so that is called deferred. So you had an asynchronous remote procedure call, which was that one there. The result was deferred. It was brought back later on, and you continue. So we end up having deferred remote procedure. So it's asynchronous. You responded, and for the client in terms of acknowledgement, you do the processing and return the result later. Deferred remote procedure. And we said usually this happens when you are not expecting a result back. But of course, you can also expect a result. The beauty of not expecting a result is that basically the information is not going to change your computation moment in time. Okay, so let's try now to look at some applications. Okay, some applications of this remote procedure calls. So one of the areas that it has been applied is what we call the distributed computing environment. Okay, in the distributed computing environment, we end up having a computer okay, where the request was being made, okay. I hope you can hear me. Okay, when the request was being made, okay, this particular client, okay, makes the processing, and then the result can be brought back later. So these ones can be geographically scattered, okay? And a good example is what we refer to as a good example is whereby we refer to as a distributed computing environment. So the distributed computing environment is a good example of this. And so it makes it easier for application programmers not to be aware of their of the different programs the way they are being run. So if this is happening, you will find that the implementation you are doing on the distributed environment, you don't have to worry about how that is going to be done. Okay, so a good example is what we call the open group. Okay, the open group remote procedure call, and this one here has several services. We are going to focus on remote procedure call, but it also provides distributed file service, provides directory service, so name lookups. Remember, we said you have to identify which are the resources that are there. It provides synchronization. So we have said one of the issues on a distributed environment, times are different. It provides multi-threading. Multi-threading means I can give you an opportunity for having a very small part of the program performing a particular task. So that's called multi-threading. Of course, there are other functions that are related. So we might have signal conversion. We'll talk about that, coding, line clocking. I don't want to go to the deep details now. We'll look at them later on. So in our case of the remote procedure call, which is our discussion now, so let's see how that distributed computing environment behaves. So for that to happen, the distributed environment provides what we call binding. You must be able to bind the client to the server. Now, in a few slides back, I mentioned as a programmer, you don't need to think about where the socket, okay? What I didn't say is that the distributed environment handles that for you. So it removes that from you, and therefore the client, the environment is the one that will handle this on your behalf. The first thing that will happen is that the server will register an endpoint. An endpoint is a location of a particular service that is provided. Let's say, for example, I want to provide a service for providing an average for maybe the marks of students. So I prepare that program or that application, and then have an endpoint which is registered on the diamond. So if you want to be able to compute an average of marks, you will ask, okay? So the moment I've provided an endpoint, so let's look at it, that is a simple, maybe, let's use a simple add, maybe an IP address, for example, okay? And then, of course, I have a socket. So the moment I have that, then now it's available. Remember, we said in this way environment, you must publish. So that is it published. As a client comes up and say, oh, I need to compute an average, okay? Then what it will do, as we've discussed, it talks to the directory server. I'm looking for computing an average. And says, or the server will say, okay, fine. Then it gives you an endpoint. I know the endpoint. Now I can be able to go. I have the endpoint, which is here, okay? And the endpoint now will refer me to the server. And that's why you now can see this. The moment now you have that, you can easily be able to do the computation. So let me rewind and say, the server will create the service, register the endpoint. After the endpoint makes it available on the directory server. The client will look for that. It's given that. it looks for the endpoint where it has to access it, and then it can be able to access that. Now that one, now they can do several back and forth, okay? Because now the endpoint has been known. So this process here is what I referred to as binding, okay? So you are binding the client to a server. And the binding basically means that you know an endpoint that you can access, and henceforth you can be able to use. Endpoints are edges in a network allowed in terms of communication where you're going to. So I'm leaving this point and I have to end up at this particular point. And this is supported by a lookup, which will tell you where those endpoints are, and you can be able to use them. Now, what we have discussed there was the normal procedure call. Now, we right now we also use method. We also use objects, and so now we can apply the same concept, but now we use the concept of objects. So we apply it now on object-oriented systems. Now, when we are using now object-oriented systems, we need to have a concept that you are aware of: functionality, interface. Remember interface, where an interface, I'm not talking about application interface, I'm looking at it as list of program method calls without the actual location, the actual implementation. That's an interface. So therefore, we'll have now different interfaces can be implemented by different objects. So I can have different objects elsewhere. I have objects elsewhere, but I know the interface. Okay, so I know the interface, but the object, the actual implementation is elsewhere. And therefore, within the distributed environment, the interface resides on one machine and the implementation can reside on another, which now makes our lives easier. So I can now have things like even runtime implementation. So object interfaces now are very key, looking at it in terms of remote method invocation. Okay, so and so if we implement that in terms of the diagram, we'll say that now we have, okay, this particular client here has a proxy that has access to the interface. So this same interface here is the same interface that is here. Same interface that is here. The only difference is that on this side, we have the interface and we have the actual objects with the implementation code. On this side here, we just have only the interfaces, which makes it very simple. So if we don't have, we can change the code on this side as much as we want. And as long as the example for the average program I was talking about, now you say, next time I want an average, I want you to compute me that average, and I want you to be able to write in this particular format. The first one was just an average, but the second one I want you to put in this particular format. I have not changed the interface, I have only changed the way it's going to be implemented and the results are presented. So now having that I can keep on changing the interface. So the client sub on this other side will help you to do the marshalling as we talked about, and the server sub will do the work done. So we have our client. In terms of objects. We are doing this in terms of objects. In a remote procedure call does not use objects. Remote method invocation uses objects. So that is something that you have to remember. But the application, the way it works, is exactly the same. So when we are now using it in this way, therefore, we end up with two things related to you. We can have compile time and runtime objects. Okay, so if you have compile time from your experience in terms of programming, flexible. So imagine when I was compiling waste my time. But if I have runtime, it means that I can compile. You can change your implementation as many times. As long as you don't change your signature, I will still have access and be able to do it. So so we end up having this runtime. So runtime is better in terms of implementation. I can change the structure of my object. Okay, and so the only thing I can change later on is when I can change whenever I change the signature, which is the interface there, okay, using maybe object adapters, I can now be able, I need to recompile again. But as long as I have not changed the interface, I don't have to change I don't have to recompile again. So this makes now the environment easier, okay? So I can only unless I have changes in my actual code, I can have as many different objects. Many different objects making calls for the invocation, and the results will be the same. Then there's another part is when I create an object, a persistent object or a transient object. A persistent object means that the moment I create that particular object, it will remain and perhaps even on secondary memory for a long time, and other users or other clients might reuse it. Okay, it has an advantage because, for example, if you are counting how many objects are trying to access a particular server, you might just want to have a persistent object. Object one comes, client one comes, I count one. Client two, I count. Client three, because I have an object that is counting them. Okay, so I might want to use it that way. But a transient object does not persist. The moment the server exists, that particular transient object is destroyed. Okay, which one is important? Of course, which one is better is subject to controversy. Because supposing, okay, part of the reasons of controversy will be, supposing that object disappears, we'll see a bigger problem in distributed environment, which is called garbage. So we need to find ways to. So supposing it cannot be accessed, it becomes garbage to the system, and so it's a problem. Okay, but you have seen there are, of course, potential advantages to that. Now, when we are using remote procedure calls, we also have to think, what is it that we are passing? I might be able to pass, okay, in this regard, I might be able, so this is my local object, okay? I might be able to pass something here. I might be able to pass the object itself, okay? So look at this structure. I have, let me pick this one here. Remote invocation with L1 and R1 as parameters. So I'm just passing them as parameters. Okay. There's another one here where is my arrow? Okay. So this one I'm passing here as a remote. So we are saying this other one, I was passing parameters to this location here. Okay. Here, this location here. While in this other case here, I was using remote procedure calls. So this one here and this one here. The two implementations can be the same. The only difference will come, one, I am using a remote procedure call. So this one is relying on that object. This one is relying on this particular object, remote, okay? But there's another one here where I'm passing the parameters, okay? And then now I have the implementation. So server code here is this one here. Okay, I'm using an arrow there. This implementation here, we can use it as a remote object. The remote object is the one that implements. So machine B, okay, let me go back here. Machine B here implements, but is using an object that is here, and is using another object that is here. Remember, these are remote. So you can see the dotted arrow that I'm using is here. So remote reference, okay? Or I can copy. So when I copy, I have remote invocation with the parameters. When I copy, if I don't copy it, I am using the object at its origin. So that is by reference. If I copy the object, I have by parameters. if I have used it based on where it is residing, it is called a remote reference. What is the importance? Supposing I have code that I'm not allowed to copy, I can only use remote reference. But if I'm allowed to copy, I can be able to have it by parameters. Okay, I can have it by parameters and I can pass that. It's an advantage to a distributed environment because it gives you an opportunity to be able to say which objects in my environment can be copied and which objects cannot be copied. Now, that's important. Supposing you have code that is very sensitive, you just want clients to be able to access and simply use it without knowing how it's implemented. Let's assume it's IP. It does some very nice work for people, but you don't want them to know, so you can use by remote reference. Or you have code that you don't care, you are not worried, it doesn't have maybe IP, you just want people can copy it, so you have that by passing parameters. Now, the other thing about objects, again, in the distributed computing environment, when we have server machines, the server machines can decide. We have several clients. Okay, client one, okay, I can give you your own dynamic object. Okay, client, I can give you your own dynamic object. So these are dynamic objects. So remember, this here, so let me use this. This is a server which gives each client its own dynamic object, and it's private. When client one finishes, that object is destroyed. Client two finishes, that object is destroyed. Client three finishes, that object is destroyed, and the server can clear. Maybe let's call that was taking memory space. It clears that and then waits. So basically, what the server is doing, it will always be able to create a new server. Remember, in this case, remember it's a server. The object provides a service from our earlier discussion. Yeah, so it gives each of these clients its own independent server. And under specific cases. There's another part where we can say, oh, no, we can simply say client one, they use a shared server. So we have client one will use it, client two will use it, client three will use it. So this, of course, has potential inconsistency. So we need to have a mechanism that ensures that the data is not inconsistent. Okay, and finally, so we have two ways there, where we have a shared and where we have, shared object, and we have one that is not shared, which is specific. Just to finalize on this, the remote procedure call, of course, one example is, of course, implemented in terms of Java. So Java implements this. So, and of course, it gives efficiency. So Java does not support remote procedure call. It only has distributed objects. And so whenever you writing saying synchronized, you are simply saying now, usually in most of those cases, you are trying to say that is an example where you want that things are now organized so that there's no remove conflict possibilities. So the distributed object is stored in a server, and remote clients can be able to through proxies. Okay, and so the client, another service as another class. So we end up from what I've said, now you can be able to implement remote procedure calls and remote method invocations are two techniques that are used to implement distributed environment. I can be able to invoke my clients. I can be able to invoke servers that are distributed widely across the globe. Questions? I think let's speak questions. I think we have one. Okay, so maybe let me remove the. So one of the things now I have done. I think now that we are finished at this level, we'll look at now tutorial exercises. In a face-to-face scenario, we sit and discuss, so usually it doesn't have credit. But now, since you are working alone, I'll have the first ones because I want people to master the fundamentals before we can talk at a higher level in terms of some of the it has to reach me by Wednesday next week, and I will give another one on Monday. So you have to reach me by Wednesday next week. Please use it because it's very, very important for you to understand these terminologies that we're talking about. Yeah, and so we'll have them. There are 5. You'll see the credit for each one of them. And please send. I'll try to set up something in the e-learning tomorrow so that you can hand in there. If I'm not, then you can send me by email. So otherwise, let's work together. I'm sure things will be much, much better. Okay, I was saying that Wednesday next week, I am sending a tutorial. So that tutorial, please work on it. And it has a credit, so you will send me by Wednesday next week. Okay, so we have finished the introduction and communication, so that's why I wanted to have this. The question Moses is asking, does remote procedure call consume more time than remote local method invocation? Yes or no? Impact is on the communication side. Okay, so if I'm looking at it, you are saying local method, for example. So we are looking at it in terms of communication because you see if you have a remote procedure call, you're going to go from your. So we can look at it in terms of latency across the network. So that's the time. But if you assume there was no latency, the impact is basically nearly the same. But latency is the key. So it depends on how well your network is. Okay. So thank you very much. See you on Wednesday so that we can have some other new things you can pick up. Have a good afternoon and please take care of yourself.